Okay. All right, y'all. Okay, let's go. Let's get started. Okay, so for these, how are you going to decide whether they are parallel, perpendicular, or neither? You have to compare the slopes. What's the slope of this first one? 5x. Now, how do we find the second slope? You can. That's great. That's probably what your Algebra 1 teacher taught you. But there is a shortcut. You can do the opposite of A over B if it's in standard form. AX squared. Oh, no, that's a different standard form. If it's in AX plus BY equals C, which this one is. So it would be the opposite of 1 over B, which is 5. So what's the relationship between 5 and negative 1/5? They are perpendicular. Remember, the upside down T means perpendicular. Okay. The second one, B, what's the slope of the top equation? That one's -2. Now, the shortcut that I just showed you does not work for that second equation because it's not in standard form. So you do need to go ahead and isolate y by dividing by 3. So y equals -2x minus 5. So what's the slope of that one? -2. So what's the relationship? Parallel. That's not 11. That's parallel. Okay. Now with C, those are both in standard form. So I can do the shortcut. Opposite of A would be -3 over B, which is 4. This one is opposite of A, 4 over B, which is 3. So what's the relationship with C? Neither. Okay, because they are the reciprocal, but they're not the opposite reciprocal. So this is just neither. This one's parallel. I feel like my virtual kids are not going to get that. And this is perpendicular. All right, get out last night's homework so we can check that. That's where we're going to start for the day. Let me see. I have it printed. Anybody have trouble finding the study guide? If you were looking for the study guide, anybody have trouble with that? No? Remember, that is still available to you if that is something you're wanting to do. Start studying. Also, don't forget that Friday, my in-class students, you get a little bonus opportunity if you choose to wear Christmas clothes. I think I've thrown my homework away. It's just for y'all. They have plenty of ways to get extra help at home taking a test. I guess I'm gonna have to print that homework out. Hold on one second, y'all. Okay, sorry, y'all. I thought I had that. It's coming. All right, last night's homework. What's your questions? Let's zoom out. Is that okay? No questions with those? Y'all have been steadily sitting there playing. You're not wearing your mask either. Anybody got questions on these? 14, sure. Number 14, we are, oh wait, I don't, oh yeah. I was like, wait, I can't see that one. 14, the answer is 15. All right, everybody good with their homework? Nobody has homework questions? Number 12. What was what? 14? Yeah, 14 is 15. Anybody else have questions? All right, get out your kites. The lesson on kites. Not like your actual kite. Like we're not going kite flying. All right. Now, yesterday, I gave you this graphic organizer. Okay? So, on this graphic organizer, you have like, we didn't discuss this, so I want to do this real quick. You've got like the parallelograms. Well, the parallelograms stream into all of these. All of these are connected back to the parallelograms. The rhombus and the rectangles are connected to the parallelogram. So whatever's in the parallelogram, these also have. And the square has everybody. So all of these are like in the same family. You know, like they're same family, kind of like cousins or whatever. But this little line separates the trapezoid. It is its own thing. Okay? Trapezoid just sets off to the side. It doesn't have two sets of parallel sides. All of these over here have two sets of parallel sides. Trapezoid doesn't. It only has one set. Okay? Now, kites is its own thing as well. Okay? Has its own properties, but it is still considered a quadrilateral. That's why it's in the same unit, because this whole unit is on quadrilaterals, four-sided shapes. So when we look at a kite, it says a kite is a quadrilateral with the following properties. Okay, exactly two pairs of consecutive congruent sides. So consecutive means that they are touching each other. So if we look at this, AB is consecutive to AD. And those two things are congruent. Okay, I'm going to zoom that in a little bit. Okay, then over here, BC is consecutive to CD, and they are congruent. So we've got exactly two pairs of consecutive congruent sides, and then it says one pair of opposite angles are congruent. So one pair of opposite angles, in this case, it's A, B, C, so this top angle here, and ADC, that angle there. Those two angles are congruent, not A and C. Okay, so we've got that one pair. And then it says the diagonals are perpendicular, which means that they form a 90-degree angle. So those are our properties for a kite, and that's what we're going to be practicing today, is figuring out what to do with kites. All right, now how many total degrees are inside a kite? .360. Okay, so a kite is the same as all other squares, rectangles, anything that has 4 sides is going to have 360 degrees. So all of these kites are also going to have 360 degrees. So when we look at number 1, we have to know that bit of information to figure that out. Angle B and angle D are going to be our congruent angles. They are congruent to one another because it says you have one pair of opposite angles that are congruent. Well, obviously 85 and 43 are not congruent. But what's the sum of 85 and 43? 128. Now, they don't have to be supplementary. They don't have to be anything. They just are 2 angles that make a kite. How are we going to get B and D from the fact that we know 128? Good. You've got to take the whole 360, subtract out what's already used. 360 minus 128 is 232. And then we're taking that and dividing it by 2. So what's 232 divided by 2? 116. And they are both 116 because they are going to be congruent. You try number 2, like super fast. Who's 82? J. You know J is 82 because these sides are consecutive. These sides are consecutive and congruent. It's the angles that are in between those. So this one is going to be 82. So we've got 82, 82, 71. What's going to be left? What's left? 125. Make sense? Okay, number 3. This one has our diagonals drawn for us, and it's giving us this little angle here, 37. Okay? Now, what do we know T, angle PTQ is? 90. So we're first of all looking for PTQ. Well, we know that's 90. Then we're looking for PQT. So this little angle at the top. How are we going to find that little sliver? What is that I just drew in that green olive color? It's a triangle. It's not necessarily a, not necessarily. It's just a triangle. No, just the sum of the angles is what? 180. So since the sum is 180, we just subtract out the 37, that's over here at P, the 90, that's at T, and that's going to give us what's left over. What's 180 minus 37 minus 90? 53. So that means up top, Q is 53. Now, it did not tell us anywhere in the properties that our angles are being bisected. Okay, so we can't just assume that this side's 37, so this side's 37. This side's 53, this side's 53. We can't assume that. Doesn't say anything about them being bisected. So now we're looking for QRT. QRT is this angle over here. How do you know what that's going to be? Well, it's going to equal 37. And how do you know it's going to equal 37, Kyle? Well, they're on the same side, but you can see that they are intersecting congruent sides. This side's congruent to this side, right? So it's like making that same cut, making that same angle. So that means this is going to be 37 as well. So we don't know that the bottom half of this angle is 37, but we do know that it's like base angle is the same, because it just clicked to me. It is a base angle, because what type of triangle is this big triangle here? It's isosceles, okay? So that purpley angle that I just drew is an isosceles triangle. Well, the base angles are the same. They have to both be 37, okay? Cool. Now, let's look at number 4, okay? They give us D up top, G, D, H, and they want us to get G, D, E, okay? The whole thing. Well, how are we going to get that? You know that this side's 59, okay? We got this 90-degree angle. We have this base angle, G, that's going to be the same as this base angle, E. So since both of these are 90 and both of these are the same, what can we assume that the top two are going to be? They're going to be the same too, because you're dealing with the same little tiny triangles. Yeah. So what is 59 plus 59? So the whole thing is going to be 118. So wherever you find the longer of the diagonal, well, not necessarily the longer. Okay, this angle and this angle, E's split is not equal. G's split is not equal. But D's split is equal, and so is F's split. So with a kite, there are going to be equal angles because there's symmetry. You know, you could take that and you could fold it and it will be right there on top of each other. If we use D and F as our line of symmetry, I could fold E directly on top of G, right? So those are going to be mapped onto themselves. Those are going to be the same. But if I try to fold it at GE, will it map onto itself? No. So that's the difference in the fact that this way we've got some congruent angles, but this way we don't. I don't know if that makes sense. Hopefully it does. Okay. All right. So now we're looking at DEH. DEH. This little angle here. You can think about either the isosceles triangle or you can think about the right triangle. You've got different ways to do it. Doesn't matter to me. Okay, yeah, because you're just using the small triangle. Okay, he's using this triangle or the other way. So we've got the 90, which is at the H, and we've got the 59. So you're doing 180 minus 59 minus 90. What's that going to leave you with? 31. Okay. Then we're looking for DGH. What's that one going to be? Same thing. Isosceles triangle. Those base angles are going to be congruent. Number 5. All right. We got all the angles on number 5. They gave us lots of information. So let's just jump with what we know. Who is also going to be 52? 7 is going to be 52. What's angle 3 going to be? It's going to be 90. Okay, so now let's focus right here and find 1. If we know that that's a 90-degree angle, and we know that we've used 65, how many degrees are in that total triangle? 180 minus 65 minus 90 is going to leave you with 25. So who's going to be 25? 1 and 2. Because remember, we have symmetry. All right. So now we need 4, 5, and 6. So we can do that. This time we're just going this way. So What are the degrees that have already been used of the small triangle? 90 and 52. So subtract out 90, subtract out 52, and that leaves us with 38. Who's 38? 5 and 6. So the only one we haven't found is angle 4. What's angle 4 going to be? Yeah, it's going to be symmetric to that 65. It's going to map onto it, so it is going to also be 65. Okay? All right, we got to rock and roll. So let's go down to number 7. If we look at number 7, it says, if WX is 14 and WR is 8, find RZ. How are we going to do that? The Pythagorean theorem. Because if this is 14, that's 14. So what you're looking at is you're looking at a little right triangle. So this is 8 over here. This is 14. This is my unknown. So who am I missing? The leg or the hypotenuse? I'm missing a leg. So I've got 8 squared plus x squared equals 14 squared. What's 14 squared? What's 8 squared? So I subtract 64. What's 196 minus 64? Okay, is 132 a perfect square? No. So we're going to get as close as we can. 11.5. Thank you. Okay, so that's RZ, because that's what we were looking for. So we know that RZ is 11.5. What would ZT be? I'm sorry. What would ZX be? Good, because you would just double it. All right. Now AC, the entire thing is 38. Then ED, which is this smaller portion from the middle down to this vertex, is 41. And it wants us to find CD, this segment on the outside. How are we going to do that? Good. You've got to take that 38 and divide in half. What's 38 divided by 2? So this is going to be a right triangle. We've got 19, 41, and our unknown. Who are we missing? A leg or a hypotenuse? That's the hypotenuse because here's your 90-degree angle. So we're missing the hypotenuse. We've got 19 squared plus 41 squared equals x squared. I'm just going to type in 19 squared plus 41 squared. And that gives me 2,042. And then we have to take the square root of that, which gives me 45.2. Everybody okay with that? And that's CD. Questions? So we're doing lots of things with right triangles. Easy. I like right triangles. All right, let's look at the second half. Number 9. Number 9 up here says if RS equals 10, so that's 10, and RU equals 9. They want you to find QS. How would we go about doing that? Good. Whatever US is, you just have to double it. Okay? So is US a leg or is it a hypotenuse? So 9 squared for A squared, X squared for the other leg, 10 squared for the hypotenuse. You're missing a leg. So that's 81. That's 100. We have to subtract 81. What's 100 minus 81? Then we take the square root of 19. That gives me 4.4 for x. So 4.4 is US. So how are we going to get QS? Double it. So what's QS going to be? 8.8. Number 10. If GF is 15. Okay, GF is 15. CG, this middle section is 23. Find CD. We're not going to do this, we're just going to set it up. How would you set this one up? That's a leg plus 15 squared, because if this is 15, this is 15. What we don't know is our hypotenuse. And then you would just solve it out. Number 11. What do we know about those two angles? They are congruent. Okay, those are two congruent angles. So 13x minus 32 equals 7x plus 22. So you just solve it out. So I'm going to subtract 7x. 13 minus 7 is 6, right? Add 32 for 54 divided by 6. X equals 9. Okay, for number 12, what do we know about those two angles? They are congruent. This side and this side is equal. This side and this side is equal. So those two angles are in between there. I'm not going to, well, they want you to find L. How would you take this and find L? That's right. Set them equal to each other. Solve for X. Plug it back in. Look at number 13. Okay. Number 13 is definitely going to be a bit different. Are these two angles A and C congruent? No. But if this is 109, that's 109, right? Because those are congruent. So how are we going to go about solving for X? That's right. Take all of this, add everything together, and set it equal to 360. I'm going to do a little bit of the math. 109 plus 109. I'm going to go ahead and add that to get 218. So 218 plus 5x plus 14 plus 3x plus 8. That equals 360. I do not have enough space for this. Combine your like terms. So we've got 218 plus 14 plus 8. That gives me 240. And then my x's are 5x and 3x, which gives me 8x. That equals 360. Y'all okay with that? Did I lose anybody? Subtract that 240. 8x equals 120, right? Divide by 8. X is equal to 15. Now, look at 14. They give you the little angles, and they want you to find STV. How are we going to find this angle STV right here? Good. You know that these two plus that 90-degree angle forms a triangle. Okay? So you would do 9x plus 1 plus 23x minus 7 plus 90 equals 180. Or what you could do is you could just take these two and set them equal to 90, because you've already used 90 of that, so you could just mental math 180 minus 90. But this is fine. So then we've got 9x and 23. That's going to give us 32x. 1, -7, and 90. That's going to be 84 equals 180. Subtract 84. 32x equals 96, right? Subtract, not subtract, my bad. Divide by 32. And what's that equal? 3. But that's not our answer. Good, because R is going to be the one that is the same as T. R and T are going to be congruent, so I'm just going to take that and do 9 times 3 plus 1. 9 times 3 is 27 plus 1 is 28. Yes, sure. Number 15. We're looking for F, G, J. F, G, J. This angle here. How are we going to find that? Use that little triangle, maybe? Or what do you know about these two things here? They're equal to each other. So you have options. You could set these two things equal to each other and then just deal with the degrees. That's totally fine. Actually, that's what you're going to have to do. Just kidding. There's not options. JK. So subtract 2x. That's 3x. Add 1. That's 12. Divide by 3. X equals 4. Now, here's where we can go about figuring it out. So what do we need to do first? We need to plug it in so we can figure out what the degree is at the top. 2 times 4 is 8 plus 11, 19. So the angle up top is 19. The angle here is 90. So we do 180 minus the 19 minus the 90. Whatever's left is going to be the other angle. What's that going to be? 71 degrees. Questions? Okay, this time we're looking for NQP, the whole thing. We want that entire angle, but how are we going to find it? Well, the information that they gave us gives us the angles of a triangle, right? Because whatever this 4x minus 7, if it's this side, it's also that side. So you've got 4x minus 7 here, 11x minus 23 here, and this angle here is 90. So together, what's all that have to equal? 180. So we've got 4x minus 7, 11x minus 23. So I'm going to add that together just to simplify my work. That's 15x minus 30 plus the 90 equals 180. Because I'm dealing with that purple triangle. This angle plus this angle plus 90 equals 180. So then we've got 15x plus 60 equals 180. Subtract out 60. 15x equals 120. Divide by 15. What does x equal? Okay. Now, how are we going to get the actual angle in green? Plug it into Q. So 4 times 8 minus 7. 4 times 8 is what? 32 minus 7. What's 32 minus 7? Now, 25 is half of the angle. So you've got to multiply by 2. So the whole angle is 50. Okay, some of us didn't take great notes today, so I want you to submit your notes and your homework. So if you didn't take good notes today, you need to get with somebody and you need to get yours caught up. Okay, you have to take notes in class. It's not optional. Okay, so get your notes. Everything on this front page should be done. And then you guys are working on the evens on the back. Yeah. Just like I did in class. My virtual students, you always submit your notes and your homework is also the evens. Evens. Everything on the front and then the evens. So I want to see your notes and I want to see the back.